Welcome to session 6. The topic we'll be discussing in this session is mobile network layer, and we'll be discussing this session under these headings. We'll be discussing mobile IP, followed by that we'll be discussing dynamic host configuration protocol, and then we'll be discussing mobile ad hoc networks. Let us start with the learning objectives. After going through this particular session, the learners will be able to understand the need for mobile IP. That is why traditional IP, which is used in wire networks, cannot be used for wireless networks. Uh, why an upgraded IP, which is mobile IP, is required? So, what is the goals, assumptions, and requirements of mobile IP, and how IP packets are delivered in mobile IP, and how a node is discovered in mobile IP, and how a mobile node registers itself when it moves from one place to another place, and how the concepts like tunneling and reverse tunneling work. These things the learners will be able to understand. And also the students will be able to understand the concept of DHCP, Dynamic Host Configuration Protocol. The students will be knowing the working principle of the routing algorithms like destination sequence distance vector routing algorithm, dynamic source routing algorithm, and also they'll be getting an overview about ad hoc routing techniques. Okay, so this is the learning objective of this particular session. So let us start with mobile IP goals, assumption, and requirements. Okay, so the traditional IP cannot be used for mobile networks, because in a mobile network the mobile station, that is the mobile phones, will be keep on moving, and still if you want to access the internet, then it cannot be done with the traditional IP. The reason is the traditional IP need a topologically correct IP address. Topologically correct IP address. That is, if a host sends an IP packet with a header containing the destination address, the destination address not only determines the receiver of the packet. Okay, the destination address not only identifies the receiver of the packet, but it also identifies the subnet to which the receiver belongs. Okay, so for example, if there is a destination address something like this, 129.13.42.99, it means that the receiver must be connected to the subnet with the prefix 129.13.42. Okay, so the routers in the internet will look for the destination address of the incoming packets, and then forward it to the lookup tables. Okay, so basically first the packet will reach the subnet, and from subnet it will be routed to the particular node. Okay, but in a mobile network, what happens? The mobile station keeps moving, so you cannot provide a fixed IP address. You cannot provide a fixed IP address. So that is the main reason why traditional IP cannot be used for mobile communication. Okay. Okay, fine. So to overcome this problem, there are some quick fix solutions. There are some quick fix solution. So one solution is, instead of using uh, a fixed IP address, let us go for an DHCP, which means dynamically host configuration protocol. That is, dynamically the IP will change whenever the mobile station moves to a new location. Okay, but here the problem is, yes, DHCP concept is already available, so there is no issue in providing a new IP address whenever the mobile station moves from one network to another network. But the problem is this new IP address will not be known to anybody. Okay, nobody will be knowing about this new IP address, and it is impossible to find a mobile on the internet which has just changed its address. Okay, so whenever it goes to a new address, whenever it goes to a new location, it will have a new IP. And now it is impossible to identify or locate this particular mobile device which has just changed the IP. Okay. Okay. So to overcome this particular problem, already there is a solution in traditional IP, and that is called as dynamic DNS. So DNS stands for domain naming system. So dynamic DNS is something by which the logical name of the computer can be updated with the logical name of the computer will be mapped with the IP address, and it will be done dynamically. Okay. So we can say that already the traditional IP has a feature called dynamic DNS, and by using DHCP, if we adopt dynamic DNS, then uh, then 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 the mobile node which is moving will have an IP address, and also others will be knowing about this IP address. Okay, but the problem here is but the problem here is DNS needs the domain naming system. DNS needs some time before it updates the internal tables necessary to map a logical name to an IP address. Okay, so DNS needs some time before it updates. It cannot update just in a fraction of second. It needs some minimum amount of time to update the internal tables and to map the logical name to a physical address, IP address. Okay, logical name means the computer name. Computer name will be same, but only the IP address will change whenever it moves. So it has to map the name with the IP address, but it needs certain time for that. It needs some time for that. Okay. So so basically this concept of dynamic DNS, it won't work with mobile nodes. It is okay with a normal computer. If you are taking your laptop and you are plugging somewhere else, it will take time, and after sometimes it will identify. But that may not work with mobile node, where it should be identified immediately. Okay. So so this is the problem with dynamic DNS. Okay. So what we have discussed so far, in the sense, traditional IP cannot be used for mobile networks. The reason is traditional IP has fixed IP address, and these IP addresses are routed through the subnet, and and part of the IP address actually refers to the subnet. Okay, so we cannot give a fixed IP address for mobile stations, because mobile stations are keep moving. So one of the solution proposed for this is go for DHCP, Dynamic Host Configuration Protocol. It is dynamically allocate the IP address. Okay, but if we dynamically allocate IP address, then whenever the mobile station goes to a new network, and if a new IP address is assigned, then nobody will be knowing about this new address. Okay, fine. This problem can be rectified by using traditional IP itself, by using a concept called dynamic DNS, which will map the logical computer name with the IP address. But the problem with DNS is not that speed. It, it, it needs some time to update the internal table and to map the logical name with an IP address. So this concept will not work with mobile nodes, because mobile nodes moves quite often, and it should be updated at a very faster rate. Okay. So internet and DNS are not filled or not built for frequent updates. Basically, DNS is the one which supports frequent updates. Okay. So this is the reason why DNS cannot be used for DNS cannot be used uh, with uh, with with mobile devices. Okay. So just imagine millions of devices moving at the same time. Then what will happen? DNS will be keep on changing. and DNS could never present a consistent view of names and addresses. Okay, so and this technique will be too expensive to update quickly. If you want to make it to update quickly, the DNS, if you want to improve the DNS to update quickly, then that will be too expensive. Okay, so and also there is severe problem with higher layer protocols like TCP, which rely on IP address. Okay, changing an IP address while having an TCP connection. Say the TCP connection is already there. At that point, if you change the IP address, means you are breaking the TCP connection. Means you are breaking the TCP connection because TCP connection is a tuple. Because TCP connection is a tuple which consists of source IP address, source port, destination IP address, and destination port. So all these things combined together, it forms the TCP connection. Okay. So while having the TCP connection, if you change the IP address, change the IP address in the sense if the mobile station moves from one network to another network, then obviously the IP address will change. Then it means that it is breaking the TCP connection. Okay. So this is also this TCP connection. This tuple is also called a socket pair. Socket pair. Okay. So the point is TCP cannot survive and change in the IP address. Okay, TCP cannot survive any address change. If there is any address change, then the TCP connection will no more be valid. Okay, so there is another approach. There is another quick fix solution, and that is to create specific routes to the mobile node. And so wherever the mobile node moves, that route should be noted down, and it should be referred to the routing table. So in that case, the routing table, the job will be done through the routing table. It is the mobile node can be anywhere, but the routing table should be able to trace it. Okay, but the problem here is, but the problem here is routers uh, always choose the best fitting prefix for the routing destination. Okay, but the problem with this approach is routers are basically designed for extremely fast forwarding. Routers are basically designed for extremely fast forwarding, but not for fast updates. But not for fast updates. So you cannot quickly update a routing table at the rate what a mobile phone requires. At that rate, routing tables cannot be updated. Okay, because forwarding routers can do fast forwarding because forwarding in the routers are done through special hardwares, whereas updating the routing table is done by softwares, okay, which cannot handle frequent updates. So these are done by the softwares, and it cannot handle frequent updates. Okay? And routers are the brains of the internet. Routers are the brains of the internet, which holds the whole internet together. Okay, so no service provider or system administrator would allow changes to the routing table, probably sacrificing stability. Okay, so this is also one of the reason why this routing table approach cannot be followed. Okay, so basically what we discussed here in the sense the traditional IP cannot be used with mobile IP, cannot be used for mobile networks because traditional IP protocol it uses uh, the computer uses fixed IP address. Here in mobile network you cannot have fixed IP address. So for that we have discussed some quick fix solutions like using DHCP, DHCP, DNS, dynamic DNS, and by using and by tracking the mobile device through the router. But all these quick fixes it won't work with mobile devices. The reason is even dynamic DNS, even though it maps the computer name with the IP address, but it cannot do at a very faster rate. It is pretty slow. Similarly, the routers also, it is specifically designed for fast forwarding and not for fast updating. So it also cannot update at that speed which is expected by the mobile stations. So basically, these quick fix solutions will not work. Okay, so these are the reasons why we need a specialized IP protocol for mobile network. Fine. Now let us discuss about the requirements. So now we are convinced that a special IP protocol is required for mobile communication. And what is the requirement for this special protocol? So the requirement is uh, it should be compatible. It should ensure compatibility. Compatibility means what? See, already there is a base internet with computers. That is computers running TCP, IP and connected to the internet. That is huge. Okay. So this new standard, this new mobile IP, it it should not disturb the existing thing. The new standard, it should not disturb the existing thing. That is, it should not introduce changes for application or network protocol that is already in use. So people will be comfortable in whatever they are using, in whatever the browser they are using or whatever the operating system they are using, they will be comfortable with that. Okay. So mobile IP should be integrated with the existing operating system or with the existing technology. Okay. So it should not demand that user should go for a new operating system or user should go for a new browser. Such things should not take place. Only some services should be extended, but whatever the services already the user is enjoying, the user should be able to enjoy in the same way without any changes. You should not enforce that instead of doing this way, it should be done in some other way. Such things should not be there. Okay, so that is called as compatibility. That is, the mobile IP should be compatible with the existing technologies. Okay, routers within the internet should not necessarily require other software. So because of introduction of mobile IP, that doesn't mean that the router should be updated with some other software. Such things should not happen. So then it means it is compatible. Okay, then it means it is compatible. Okay, and mobile IP users should not require a special MAC protocol or LLC protocols. No. So whatever with the existing MAC or LLC, with that the mobile IP should be able to work. Okay. So it should only make upgradation to the IP network, to the network layer, nothing else. It should not change anything. It should not even change the network layer or the lower layers. It should not introduce any change in the MAC layer. Okay, such things should not happen. If that is ensured, then that is called as compatibility. It is the system should be compatible with the existing system. Okay. Then the second requirement is transparency. So which means that mobility should remain invisible for higher layer protocols and applications. That is, if the user is moving, if the mobile station is moving, the higher layer applications and protocol need not know that. Because it is not required for them. Maybe the lower layer protocols will be taking care of that change. For example, network layer will ensure that the IP address is changing, all those things, and whatever the procedures. But it is not required for the higher layer protocols or the applications to know that. They may notice some reduction in the bandwidth or some interrupt in some services. Okay, but higher layer should continue to work even if the computer has changed from one network to another network. Okay, so that is the point. Okay, so the mobility should not be visible to the higher layers. Okay, so uh, so so there are some applications. So generally mobility should not be known for the higher layers, but there are at rare cases there are few applications which are called as mobility aware applications. There are few applications in the higher layer which are called as mobility aware applications. These applications may be given information about the mobility because they can take advantage of mobility. Because they can take advantage of mobility. For example, assume that there is a cost based routing, there is a cost based routing or video compression. Okay, the video compression application is running. Okay, so if assume that knowing the current location may help the user, to switch to a different network so that it will be cheaper for you. Okay, say the user is running an application which is a cost based routing or a video compression. So if the mobile is in some other network, then if the mobile is now able to get a better service with a reduced cost, and then if the user is aware that the mobile is in the current location, then he can avail that service. Okay, so there are some applications which can perform better if they know about the location. Okay, so only such applications, if they know about the mobility, only such applications should be known about the mobility, and so that they can take advantage of the mobility. Otherwise, it need not be known. Okay? That is the second requirement. The third requirement is scalability and efficiency. So introducing new mechanism should not should, should not affect the efficiency of the system. Okay, in spite of the new addition, that is, in spite of adding the new feature called mobile IP, the system should be able to perform efficiently. Okay, so special care has to be taken considering the bandwidth of the wireless links, because many mobile system will have a wireless link to an attachment point. So only some additional packets should be necessary between a mobile system and a node in the network. Okay. So as the number of devices increases, so the number of devices will obviously increase. So anything can participate in the communication. Any device can become a mobile device. Okay, for example, it may be a car, truck, or it may be every seat in a car. Okay, if there is a SIM card attached to that, then that will become a mobile device, right? And if okay, so many of them will have some implementation inside and move between different networks and require mobile IP. So as the network grows, the efficiency should not be compromised. That is the third requirement. Okay. There is one more requirement which is left out, that is security. So let us add here the fourth requirement is security. So here we have the fourth requirement, which is nothing but security. Okay, so basically the mobile networks are, you cannot say they are very secure. Okay, because they are highly uh, mobility poses many security problems. Mobility poses many security problems. So some minimum level of security should be guaranteed. The minimum requirement is that all messages related to the management of mobile IP are authenticated. The minimum requirement is that all messages should be authenticated. Okay. The IP layer must be sure that if it forwards a packet to a mobile host, that this host receives the packet. IP layer should ensure that if it forwards a packet, it is received by the destination uh, node, that it should be able to confirm. Okay? And also it should be able to guarantee that the IP address of the receiver is correct. Okay? It should be able to confirm that the packet is reaching the destination properly, and also it should be able to guarantee that the IP address of the receiver is correct. Okay. But there are no ways to prevent fake IP address or some other forms of attacks. Okay. So basically, it should provide some minimum level of security. So these are the requirements of mobile IP. Okay. So So that's it about the goals, assumptions, and requirements. So basically here what we have discussed in the sense, first we have discussed like why traditional IP cannot be used with mobile IP. Because traditional IP uses fixed IP address, okay, and mobile stations cannot be given fixed IP address because these devices will keep moving. So then why can't we use DHCP? Fine, DHCP can be used, but the problem with DHCP is if you use DHCP, whenever the IP address change, others will not be knowing about that. So nobody will be able to reach that particular mobile station. So why not we use dynamic DNS so that the system name can be mapped, so that the logical name of the system can be mapped with the IP address. Fine, dynamic DNS can be used, but dynamic DNS will not update the thing very fastly. Okay, so but the mobile stations will be keep moving. So dynamic DNS cannot update things at that faster rate. Okay, so basically that technique cannot be used. So then why can't we use update the things in the routing table whenever a mobile station moves? So again here routing tables are specifically designed for fast forward and not for fast updates. So it cannot be done through routing table also. Okay. So these are the motivation why we need a special IP called mobile IP. Okay. So then we have discussed the requirements for the mobile IP. The requirements for the mobile IP is compatibility. That is, it should be compatible with the existing technology. The existing technology should not change or should not upgrade. So with the existing technology, the mobile IP should be able to work. Transparency. The higher layers need not know about the mobility. Okay, the higher layers need not know about the mobility. Only they may experience lower bandwidth or some interrupt in some services. There may be in the higher layer, there may be some mobility aware applications which can take advantage of the mobility. Maybe such applications can be given information about the mobility. And then we have discussed about scalability and efficiency. As the network scales, as the network increases in size, because any device can become a mobile device and it can participate in the mobile communication. So so anything anything and any other device can be a mobile device. It may be a car, truck, mobile phone, or uh, every seat around the world. Okay, so many of them will have some implementation inside, and they may move between networks, and they may require mobile IP. So it is crucial for the mobile IP to scalable over a large number of participants in the whole internet worldwide without compromising the quality, without compromising the efficiency. The scalability should be ensured. Okay, so that is about scalability and efficiency. Okay, and then we have discussed about security. So mobility possesses many security problems, but it should ensure some minimum security requirements, like all the messages related to the management of mobile IP are authenticated. All messages should be authenticated. The IP layer must be sure that if it forwards a packet, if it forwards a packet to a mobile host, it should be able to ensure that the host has successfully received the packet. Okay, and also it should be able to ensure that the IP address of the receiver is correct. Should be also able to ensure that the IP address of the receiver is correct. So generally there are no way to prevent fake IP address. Okay. So according to the internet philosophy, this is left to the higher layers. Detecting fake IP address, all these are left to the higher layers. Okay. So the goal of the IP, mobile IP, can be summarized something like this. The goal of the mobile IP can be summarized something like this. Some, supporting end system is mobiles. End system is mobile. Supporting mobile or end system mobility while maintaining scalability, efficiency, and compatibility in all respects with existing applications and internet protocols. So this is the goal of the mobile IP. The goal of the mobile IP is is to support end systems mobility. Is to support end system mobility while maintaining scalability, efficiency, and compatibility in all respects with existing applications and internet protocols. Okay, so that's it about the goals, assumptions, and requirements of mobile IP. Fine. Let us stop here. Okay. Thank you.